Hello and welcome to the Apocalypse Session 5, Division, with me, Mr. Colley.
And me, Mr. Ward.
So, as we have just told you, today we're focusing on division. That is the idea of sharing things out. For instance, if you have 35 lollipops, sharing them between your 5 friends, and how working out how many each person would have each, or individually. Anyway, here we go. So, over to Mr. Ward now, who's going to explain, first of all, just the layout of division.
Right, so this is what we call the bus stop method, or also referred to as short division. So, there are a number of different parts here, and a number of different names for them, which you will have heard, but we'll just quickly recap them. Underneath what we call the bus stop, we have something called the dividend. Okay, the dividend is the larger number usually, and that is the number that's the total, the whole number that we're trying to divide up, that we're splitting up or sharing out. On the outside of the bus stop, we have the divisor. So that is the number of ways that you're splitting it, okay, or the number of people that you're sharing it between.
And then, when you have worked out your answer which will be on top of the bus stop, will be your quotient.
Correct. So, how do we work out, using the bus stop method, 696 divided by 3? Well, first of all, we're going to have a look at our divisor. Our divisor is a number that we're going to be counting up in. If we know our times tables, this makes things a lot easier. So I'm going to be using my 3 times tables here to calculate each of the separate parts to this answer.
Indeed. So, here we go. What we're going to look at first is how many times, or how many lots of 3 we can get out of 6, or how many times 3 goes into 6 almost. So, hopefully, if you're following us at home, we count in 3s, 3, 6, you'll realise that it goes in twice, or you can make 2 lots of 3. And that's where you would put that, the 2 that you can fit in goes above that.
So just to demonstrate that, if we had 6 of any object or anything, we're working out how many groups of 3 we can make out of that. So that's 1 lot of 3, 2 lots of 3. Okay? Interestingly, whenever you see that times symbol, that basically means of. Okay? So 2 times 3 is 6. It's also 2 lots of 3, isn't it? Is 6. Okay? So there we go. That's why part of our quotient there, we've got the number 2 up.
Okay, and now we're going to do the same thing, but with the number 9, or the digit 9. So we're going to see how many 3's go into 9. So 3, 6, 9. And the answer will be 3.
Now you want to be really careful here, because a common mistake is that people go 3, 6, 9, and they put 9 on the top. We don't want to do that. We want to work out how many multiples. 3, 6, 9. It's 3 multiples of 3, isn't it? 3 lots of 3.
Okay, and then obviously finally, hopefully, if you've already done the digit 6 here, you know exactly what's going to be here. So, 7. Yeah, 7. No. So 3's into 6 will obviously be 2.
6.
Yeah, and there you will have your quotient there, and your answer. Okay, so what we can work out from this is that if you split 696 by 3, each person of those 3 would have 232, whatever it is that you're dividing, whether it be foxes or
pieces of a fox.
Yeah.
Small, tiny.
Yeah.
Okay, moving on.
Yes.
Okay, we have a slightly harder number here, because what we've got is we've got a number for our dividend that is not going to go exactly, we're going to be exactly in the 4 times table. And if it's not in the 4 times table, then we're going to have to start dealing with what we call remainders. So, same thing as before, we're going to start off looking at the first digit in that number. This time we're using our 4 times table. How many times is 4 going to go just into that first digit, the number 5?
Okay, so yes, counting 4s, what's the highest you get to? If you go past that number that's there, then obviously that doesn't work.
Too far.
Yeah, so 4, 8. Hang on a minute, I've gone too far. That's 8 is bigger than 5, therefore
So some people might find it useful to write out their times table so that you can literally count how many times. 4, 8, 12, 16, I'm going to stop there. If I'm only going up to 5, I can get to 4, but 8 is too much, as we said.
So, 4's into 5, there is 1 lot of 4 in 5. Now, here's the problem. Here's 5. If I take that 4 away, I'm still left with 1. I'm still left with 1, as Mr. Ward has beautifully illustrated there. Thank you very much, Mr. Ward. Okay.
I'm not art coordinator for nothing.
This is true. That is the best diagram I have ever seen. So, obviously you have 1 left over as well. So we're going to put a line through that 5 to show that we've done it. And then we're going to take the 1 that I have left over, we have left over, and put it in front of the 9 to create 19. Okay, now I'm going to go back and do the same thing and see how many 4s I can get into 19. Now obviously, if we just extend, we might need to extend this as you go through. Now, as you can see, the 20 is past 19, so 4, 8, 12, 16 is the closest I can get, and that is 4 groups of 4, which means that 4 is going to go at the top there. Again, though, I'm going to have some left over, and I'll have 3 left over. So I've used 16 out of the 19, which means there are 3 left over, and that's going to carry over to there. And now I'm going to do 4s into 38, okay, which will be 9, and will leave you with 2 left over. And when you get to the end here, you can just put it as a remainder. The R here standing for remainder.
Correct. So just to clarify, when we get 4 times 9, we have 36. To work out the remainder, we need to count up from 36, we need to count up until we get to 38, 37, 38. So that's where our remainder 2 comes from. Alternatively, you could do it the other way around. You could do 38, subtract 36, and that would also give you your 2 remainder.
Correct. Now, as you may have become accustomed to with these videos,
unless this is your first time watching,
yeah,
in which case welcome.
Yeah, and prepare to have your mind blown by the high-tech solutions we have to giving you questions at home. So, yes, here are some questions. Now, as we've said before, the red questions really we're looking at years 3 and 4, but if you want to challenge yourself, please feel free to do the ones in black for the 5, 6. So there you go. I would say now is your time to pause this. We've already set it out in the bus stop method for you. Some of them will have remainders, okay, but probably not until you get a little way in through them.
Correct.
Okay, so pause it now. Okay, and now we're on to the 5, 6 questions, or anybody who wants to challenge themselves. Again, we haven't bothered putting this in the bus stop for you. We hope that you can have a go at that yourself here. That's what we're looking for. And again, there will be some of those which have remainders. Now, some of you may be sitting there thinking, Mr. Colley, I know how to do decimal remainders. Yeah, we definitely didn't work these out beforehand. I know how to do decimal remainders. Now, if you do, please don't go any further than 2 decimal places. And by all means, feel free to have a go at them with decimal remainders. We have just left them as integer or whole number remainders, though. Okay? So pause that now. Okay, and now the answers. Hopefully there is a good time lapse there between you doing those two. As you see, Mr. Plough is here with us again. He is the one who's worked out all the answers, probably. So yes, obviously we've got the years 3 and 4 answers here, and the years 5 and 6 answers here. Okay, so please feel free to check your answers now. Okay, so thank you for watching another edition of Welcome to the Apocalypse Maths with me, Mr. Colley.
And myself, Mr. Ward.
See you next time.
Ta-ra.
Bye.